Space, the final frontier. The idea of traveling beyond Earth has fascinated humanity for centuries, and today, we're closer than ever to making space tourism and interplanetary travel a reality. But there's one major challenge that still stands in the way: safety. Space is the most hostile environment we've ever attempted to survive in, and despite all the advancements in technology, it remains extremely dangerous. So, will space travel ever be truly safe? One of the biggest threats is radiation. Here on Earth, we're protected by the atmosphere and the planet's magnetic field, which shield us from most harmful cosmic rays and solar radiation. But once you leave Earth's protective bubble, exposure to high-energy particles becomes a serious problem. Astronauts on the International Space Station receive much higher doses of radiation than we do on Earth, increasing their long-term risk of cancer and other health issues. A trip to Mars would expose astronauts to even more radiation over a much longer period, and without proper shielding, the consequences could be deadly. Scientists are working on potential solutions such as better spacecraft shielding and even biological countermeasures, but so far, there's no perfect fix. Then there's the issue of microgravity. While floating around in zero gravity looks fun, it's actually harmful to the human body. Muscles weaken, bones lose density, and even the structure of the brain can change after long exposure to weightlessness. Astronauts on the ISS have to exercise for hours every day just to slow down these effects. But a trip to Mars could take months, and a permanent settlement in low gravity could cause severe long-term health problems. Artificial gravity, like rotating space stations or centrifugal force in spacecraft, might be the best solution, but building these systems is expensive and complex. Another invisible but very real danger is micrometeoroids, tiny particles traveling at incredible speeds that can strike spacecraft with the force of bullets. The ISS is designed with shielding to absorb these impacts, but a long-duration mission beyond Earth's orbit won't have the same level of protection. Even a small piece of debris could puncture a spacecraft or a spacesuit, leading to catastrophic failure. As we send more missions beyond Earth, developing stronger, lightweight shielding will be critical. Psychological challenges are just as important as physical dangers. Space is isolating. Astronauts on the ISS at least have the ability to communicate with Earth almost in real time. But on a mission to Mars, communication delays could be up to 20 minutes each way, making real-time conversations impossible. The sense of isolation, confinement, and the stress of being millions of kilometers away from home could take a serious toll on the human mind. Managing mental health in deep space will require new strategies, from artificial intelligence assistance to improved psychological training. And finally, there's the issue of spacecraft reliability. In space, every system must work flawlessly because there are no repair shops or emergency services. If something goes wrong, astronauts have to fix it themselves or risk catastrophe. Even small malfunctions can be deadly. Redundancy, automation, and self-repairing technology will be key to making long-duration missions safer. So will space travel ever be as safe as commercial air travel? Probably not, at least not in the foreseeable future. Space is inherently dangerous, and there will always be risks. But that doesn't mean we should stop exploring. Every breakthrough in technology brings us closer to safer spaceflight, and one day, it might be common for humans to travel between planets. The real question is, how much risk are we willing to accept to push the boundaries of human exploration?